Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Finally, we will talk about the last chapter is polynomial for the first semester. So before that, we will learn about introduction to polynomials and you need to know what the equality to polynomial by Miss Rara. Without further ado, so let's jump to the next slide. Okay, so our content today is the first about introduction to polynomial and then the second about equality of two polynomial. In introduction to polynomial, recall that a combination of constants and variable connected by the sign of fundamental operation of addition, subtraction, multiplication, and division is called an algebraic expression. We define an algebraic expression is a polynomial as follows. But from the definition, we can see from in our slide is an algebraic expression which comprises a single real number or the product of a real number and one or more variable raised to whole numbers power is called monomial. Example, 6, minus 2x power 3, 5a squared b squared minus 7 over 2, and 3x power 4 yz power 2, they are is monomial. So maybe you're curious what is the definition of the polynomial? Definition of polynomial is an algebraic expression in which the variable have only non-negative integral powers. Remember that have only non-negative integers. Is that the wrong? Or we can say a polynomial is the sum or difference of a set monomial. So when you find when you have the term that the term just have is let's say one term, it's called monomial, and then you mix them with the adding signs, subtraction, or anything sign, so that's called its polynomial. Example, so from here we have 3x power 3 plus 2x plus 5, 5x y power 2, 4x minus 3y. This is the polynomial because they have more than, yes, correct, more than one term, everyone. So we can see from here 3x power 3 plus 2x plus 5, they have three terms. The first term is 5. The second term is 2x. The third term is 3x power 3. So from here, we can see if the constant term is 5. And then from here too, we can see have the highest power is 3x power 3. So we can say if they have the highest power, we can say there is leading term. From the leading term, we have the leading coefficient. So from here, the leading coefficient is 3. So, and then they have the coefficient 3, 2, and 5, everyone. And then you need to remember a polynomial is said in standard form if the terms are written in descending order of the degree. So we can, conclusion is from the highest to the lowest. So without further ado, let's jump to the example. Example 1. Determine whether each algebraic expression is a polynomial. So everyone remember that if they have just one term, we can say monomial. Monomial is member or element of polynomial. So we can say this one is polynomial, big polynomial, but they just have minus x. So we can say polynomial only consists of constant terms. Okay, how about number b? Number b, so they have 5x minus 3 over 4. They is real number, so we can say this one is polynomial with two terms. How about this one? This one, yes, this is term, but remember from the definition, if the polynomial is non-negative powers, so this one is not polynomial. So we can say this one is not polynomial. polynomial. How about this one? Because this one is the power is the negative, so we can say it's not polynomial too. How about the last? The last, we can simplify this one to be x power 5 over 6 minus x power 9 over 2 plus 3x power 2 minus 3, because they doesn't have negative power, so we can say this one is polynomial. So I hope you understand to make the different polynomial or not. Okay, everyone. So now let's jump to the next slide. Okay, now this is remark. Remember that this number 1, number 2, and the number 3 you already learned in the grade 10. If the x power 0 is that the meaning they have equal 1, where the x is not equal 0. And then the second is x power 1, it's equal with the x. And then the last 1 over x power n, it's also equal with the x power minus n, where x is not equal 0. Remember that certain polynomials are given special names depending on their number of the terms. Okay, a monomial is a polynomial containing one term. Remember, mono is one term. A binomial is polynomial containing two terms. And then trinomial is a polynomial that has three terms, and etc. everyone. And then we can also classify polynomial according to their degree, correct? The degree of monomial is the sum. The degree of a monomial is the sum of the exponent of the variable. Example. So from here we can see 5x squared y has the degree 3y because in x have the power 2 and then y have power 1. So when we adding, so the result is 3. And then 6a power 4 has the degree 4 because a power 4. And then 3m power 3 and power 2 has a degree 5 because 3 plus 2. And then the last minus 2, 4 has degree 0. So that's the meaning they doesn't have power. We can say 0. So remember that this one 5x squared y is a monomial. When we mix them, it's to be polynomial. So without further ado, so let's jump to the example. The following expression are polynomials. Find the possible natural number value of n. Remember everyone, if the polynomial power is non-negative power, or we can write is the power it should be more than 0, or we can say the degree. Degree must be more than equal 0. So from the number a, we can see here, so you just need to m plus 2 is more than equal 0. So we will get the m is more than minus 2, and then 4 minus m is more than equal 0. So we will get the m less than equal 4, everyone. So from here, if you want to make it easier, you can make a sign here. Minus 2 is more than here, and then less than 4 here. So we will get the set of solution area. Set solution is m element of what's the inside is minus 2, minus 1, 0, 1, 2, 3, and 4, everyone. Yeah, remember that if the power, it must be non-negative powers. So from here, how about the number b? Remember that if the 24 over m, it should be more than equal 0, and then m minus 6 more than equal 0. Maybe curious why x minus m we are not counting, because we just need to using their powers. Why? Because we don't know how to try solve this one if they have doesn't compare each other, or we cannot use this x minus m with who, right? So from here we get the m is more than equal 6. Remember that non-negative power, we can see non-negative integers. So non-negative integer, so we can see the power is 24 over m is element of natural number. Correct. So from here, we get the m more than equals 6, and then 24 over m, element of the natural number. So we have the m. So you need to think what's the value of the m is consistent with the 24 over m, because they say non-integers, non-negative integer. So from here, we can see m more than 6 is 6, 7, and then etc. Or let's say, let me erase this one first. We can say in here, what's the value of the m if they call is natural number. So from here, 24 over 1 is the natural number, 24 over 2, 24 over 3, 24 over 4, over 6, over 8, over 12, over 24, right? So this one is more than 6. So you need to connect them. So what's the value consists between two of them? So we can say m is element of the 6, 8, 12, and 24. I hope you understand how to find the possible value of the numbers of m. So next, another example. So like I said before in the previous slide, you need to find the degree of the polynomial, because in here we have three terms, one terms, second terms, and then the third terms. You need to find what the highest. So before you need to find the highest, you need to write first term. First term is the power. First term power is 2 plus 5, it's equals 7. Second term powers is 1 plus 1 plus 4, it's equal with the 6. And then the third term powers is consists of 3 plus 2 plus 4. This result is 9. So from the 3 of the term, so what's the highest? Oh, so the highest is 9. So we can say this is 9 degree of the polynomial. Okay, everyone, I hope you understand. So now let's back to the slide. Note: if the degree of a polynomial is 1, then it's called a linear polynomial. A polynomial of the degree 2 is called a quadratic polynomial. A polynomial of the degree 3 is called a cubic polynomial. So in the previous example, we have 9, so you need to find what's their name, but their name is still adding with the polynomial. So now let's jump to the what is constant polynomial and the zero polynomial. From the definition, a constant polynomial is a polynomial in which the coefficient of all the variables are 0. The value of constant polynomial is the constant term. Remember that the coefficient of all the variables are 0, everyone. So you need to make everything from the coefficient to be 0. So they will get the constanta term. And then what is a zero polynomial? If the constanta term is constant polynomial is 0. So when we have the constant term, the value is 0, so that we can say is a zero polynomial. And this zero polynomial has no degree, and then they have no constant. Okay, so maybe you will be like, okay, how to make it different? So let's jump to the example. Find m and n if open bracket 2m minus 4 close bracket x power 2 plus 5 minus nx plus 13 is constant polynomial. Remember that if the constant polynomial is the all of the coefficient of the variable, all of the variable, it must be 0, right? It must be 0. So they will be stay with the 13. It's showing that constant polynomial. So it's easier. You just need to write 2m minus 4 because with the purpose is constant polynomial is equal with the 0, and then 5 minus n, it should be equal 0 too. So we simplify this one. 2m minus 4, m is equal 2, and then n equal 5. Okay, so we get the m and n already, but if you curious, we can substitute this m and n value to this formula. So 2 times 2 minus 4 x squared, and then plus 5 minus 5 x plus 13. So 4 minus 4 is 0, plus 0, so plus 13. So this one it's called, yes, correct, constant polynomial, everyone. Remember that you need to make all the coefficient of the variable 0, you will get the constant polynomial. How about this example? You need to find a if the b minus 4x power 3 minus open bracket 2c plus 6 close bracket x plus a minus b plus c is 0 polynomial. So is a 0 polynomial is make it easier is every term is equal with 0, everyone. So the first term, the second term, and then the third term, you need to equal with the 0. Yes, b minus 4 equals 0. So you will get the b is equal 4. And then 2c plus 6 equals 0. So you will get the 2c minus 6c is equal minus 3. And then a minus b plus c, a, we don't know what's the a. So b minus 4 minus 3 is equal 0 too. So a is equal with the 7. So we get the a, we get the b, we get the c. You can substitute them to be here. So 4 minus 4x power 3 minus 2 times minus 3 plus 6x plus a is 7 minus 4 minus 3. So this one is 0 minus 0 plus 0. So this one is equal 0. So this one is called 0 polynomial. I hope you understand what I'm explaining. So let's jump to another slide. Polynomial function. Definition. Every function defined from the real to real of the form px equal en x power n plus en minus 1 x power n minus 1 plus dot dot until 2x power 2 a1x plus 0 is called a polynomial function. Remember that from the previous slide, if polynomial have a standard form is writing from the highest degree to the lowest degree. In a general, we use capital letters such as P, Q, R, and etc. to denote a polynomial function. Or we can have rule in here. The first rule, in order to find the constant term of the polynomial, we substitute a 0 for each variable. And then we have px and like the previous slide, and then you need to substitute them with all of the variable 0, and then you will get the a0. So this one is constant term. And then in order to find sum of the coefficient of a polynomial, we substitute 1 for each variable. In another word, if px like the previous slide, and then you substitute all the variable with the 1, and then you will just get the coefficient, and then when you addition all, so you will get the sum of the coefficient. So without further ado, so let's jump to the example. let px equal 2x squared minus 3x plus 4. You need to find p1 and p2. So from here, this is as long as they have px equals something or some formula. So we can say they have polynomials, right? So from here, you need to change the variable, or you need to substitute the variable with the 1, and then to be 2 times 1 square minus 3 times 1 plus 4. So this one is, result is 1 plus 2 is equal with the 3. And then you need to find what's the P2. P2 is 2 times 2 square minus 3 times 2 plus 4 is to be 4 times 2, 8 minus 6 plus 4. It will be equal with the 4 times 2 is 8 minus 3, right? Minus 2. Okay, this one it's equal with the 4, 12, 6, and then the 6. Okay, everyone? So you already understand for this. So let's jump to another example. Okay. Find the value using the given data. So for the number A, we have P2, 3 from the Pxy equal with the this one it should be 2x squared minus 3xy. Sorry, this one it should be minus plus y. Remember that is coordinate system. So x is represented by 2, y is represented by 3, right? So from here, you just need to substitute them to be 2 times 2 power 2 minus 3 times 2 minus 3 plus 3. So this one is to be 8 minus 3, 6, 18 plus 3. So this one, it will be minus 7. It's easy, right? So how about number B? Number B, they're asking about you need to find px plus 1 from the px equal with the x squared minus 2x. Remember everyone, this one x plus 1, this one is x. So you need to substitute the x plus 1 for here, from to here, I mean. So you need to substitute the x plus 1 to be x plus 1 power 2 minus 2 open bracket x plus 1. So you will get x squared plus 2x plus 1 minus 2x minus 1. So you can cancel this one, so you will get the value for px plus 1 is x squared. Okay, how about the number C? Okay, so number C, they're asking about P minus 2 from P 2x minus 4 equal with the 3x squared minus 5x plus 4, everyone. First of all, you need to solve that 2x minus 4 is equal with the minus 2, right? This one is still the same with this one. Okay, and then you will get the 2x equal 2, and then you will get the x1. You need to substitute all the variable x with the 1. So from here, you continue p 2 times 1 minus 4 equal with the 3 times 1 square minus 5 times 1 plus 4. The reason why x substitute with 1, so this value is will be come back to the p minus 2, right? So you will get the 3 minus 5 plus 4. So you will get the minus 2 plus 4 is 2. So p minus 2 is the value 2. Okay, everyone? I hope you understand. So for the last, it still have the same with the number A, number B, number B and number C. So let's we continue to find the D. But before that, let me erase this one first. So everyone, when you find what's their equation, you need to make them to equal with the x plus 1 and then the x, or they is depend on the what they ask. If they ask about the value, you can using like the number C. But if they give you like the number B, you just need to substitute them already because they just have px. But it's different with the number c. They have the px minus 2 and then p2x this one. Remember that you need to make them equal, right? Because we want to convert 2x plus 1 to x minus 2. That our purpose. So from here we can write to be let's see, d 2x plus 1 it's equal with the x minus 1, right? So for this maybe you will be confused. Let we change x from this change to be a. So 2a plus 1 it's equal with the x minus 2. So 2a is x minus 3. So you will get the a x minus 3 over 2. Okay. So from here, you can continue. Okay, let me erase this one first. This one is like wasting time, but it doesn't matter. Okay. So we have the a. So you need, when you substitute them to p2x, you need to change all the variable with the a, everyone. So we can write these ones to be p2a plus 1. Sorry. Okay. There is something wrong in here. So PA plus 1, it's equal with the 4a square minus 3a plus 7. So what's the a? A is 2 times x minus 3 over 2 plus 1 equal with the 4 x minus 3 over 2 power 2 minus 3 times a x minus 3 over 2 plus 7, right? So this one is we can cancel this one. So this one x minus 3 power 2 minus 3x plus 9 over 2 plus 7. Or you can simplify this one to be x squared minus 6x plus 9 minus 3x over 2 and then plus 9 over 2 plus 7. Okay, so from here we times with the 2 all of them. So this one is to be 2x squared minus 12x plus 18 minus 3x plus 9 plus 14 over 2, right? So this one is 2x squared minus 15x and then 32 plus 41 over 2. So find the constant term of each polynomial. Remember that for the constant term, you need to substitute them with the, yes, each variable for the constant term, you need to substitute them with the 0. So when you substitute them, you will be get the Q0, it's equal 4 times 0 power 3 minus 5 times 0 square plus 6 times 0 minus 4. So you will get the Q0 is equal with the minus 4. So we can say this one is constant term, CT, yeah? So how about the B? The B is P0, it's equal with the 2 times 0 square minus 0 plus 3 power 4. This one is minus 3. So you will get this one is 0 minus 0 plus 3 power 4 minus 3. So we will get the 3 power 4 minus 3. So this one is 3399, 81 minus 99, 81 minus 3 is 78. So this is the constanta term. Easy, right? So how about another example? Another example is you need to find the sum of the coefficient of the key x to x squared minus 3 power 4 plus 5x. Remember that if you the purpose to find the sum of the coefficient, you need to change their variable with the 1, and then you will get the sum of the coefficient. 2 times 1 power 2 minus 3 power 4 plus 5 times 1. So this one it will be 2 minus 3 minus 1 power 4 plus 5. So this one is 1 plus 5. So this result, it should be equal with the 6. Easy, right? Yes. How about another example? Okay. Find the sum of the coefficient of px if p2x minus 3 equal 5x squared plus 4x minus 1. Remember that you need to remember that when you want to find the sum of the coefficient, it's the px, it should be equal with the p1, everyone, because we want to the purpose is sum of the coefficient, right? So from here, you need to make this one 2x minus 3 equal 1 because they're asking about the sum. If they're asking about the just concept the term px equal with the p, no. Okay, so from here you will get the 2x equal with the 4, so you will get the x equal with the 2. So we can change or we can substitute all the x with the 2. So p 2 times 2 minus 3 equal with the 5 times 2 power 2 plus 4 times 2 minus 1. So this one 20 plus 8 minus 1. So this one it should be 27. Okay, everyone, I hope you understand what I'm explaining today. Now we have theorem. Let px be a polynomial and let p known or po and pe be the sum of the coefficient of the terms of px that have odd powers and even powers respectively. Then we have the po or p null is okay because o is representative odd. So p1 minus p minus 1 over 2. And then when you want to find the even power respectively, so pe equal p1 plus p open bracket minus 1 over 2. So without further ado, so we prove this one. Okay, now we want to prove about the theorem. So the theorem is showing that p odd equal with the p1 minus p minus 1 over 2, and then p even it's equal with the p1 plus p minus 1 over 2. Remember everyone, if the px is equal with the en x power n plus en minus 1 xn minus 1 plus dot 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 until a2 x squared plus a1 x plus a0, where we can say this one, because we want to prove the even first, it's okay, it doesn't matter. Where n is even, so we just need to substitute them p1. So when p1 it's equal with the en plus en minus 1 plus dot 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 plus a2 plus a1 plus a0. So this is the first. And then to find the p minus 1, so minus 1, so this one is equal the, because the power is even, so minus 1, so en minus 1 minus 2 is minus en minus 1 plus dot 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 plus a2 minus a1 plus a0. So we want to adding them. So when we want to adding them, so we will get the p1 plus p1 plus p minus 1. So this one is equal with the 2. This one adding, we can adding en. So this one is to be cancel. So we will get the en minus 2 plus dot 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 plus a2 plus a0. So from this one, because we're talking about the even, so we can write the en plus en minus 2 plus dot 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 plus a2 plus a0 is equal to p even with the p1 plus p minus 1 over 2. In similar way, to find the odd, to find odd, so we can write to be en minus 1 plus en minus 3 plus dot 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 plus a3 plus a1. This one is equal with the p odd equal with the p1 minus p minus 1 over 2. I hope you understand what I'm explaining, everyone. Find the sum of the coefficient of the terms with even powers and the term with odd powers where kx equal 5x power 3 plus 2x power 2 minus 3x plus 7. So from here, we need to find the key one first. So the key one, it's equal with the 5 times 1 power 3 plus 2 times 1, 2 minus 3 plus 1 plus 7. So this one is 5 plus 7, 2, 7 minus 3 plus 7. So this one is equals 11. And then we want to find the key minus 1. It's equal with the 5 minus 1 power 3 plus 2 minus 1 power 2 minus 3 minus 1 plus 7. So this one is minus 5 plus 2 and then plus 3 plus 7, 12 minus 5 is 7. So we can write to find the key even. So this one is key 1 plus key minus 1 over 2. So from here we can see key 1 is 11 plus 7 over 2. 18 over 7 is 9. And then we want to find key odd is key 1 minus key minus 1 over 2. It's equal with the 11 minus 7 over 2 is 2, everyone. Or if you see from here, it is obvious that PE is 2 plus 7 is equal to 9, and then 5 over 3 is 2. So this is the better way to find the even powers and the odd powers. Now is the last of our topic today is equality of two polynomial. Definition first, like terms. If two or more terms contains the same variable raised to the same power, and then they are called like term. Example, 5x squared y and minus 3x squared y is like term because we are not looking their coefficient. However, 7xy and then 4x squared y power 3 is not like term because the first, they have different the powers of the x and then the y is not the same, it's not like terms. How about equal polynomial? From the definition, we will get two polynomials are equal if and only if they have like terms with the same coefficient. Like I said before, like terms is the same term is the same, meaning is the same variables but not the same coefficient. But equal polynomial, they have two. The first, they should have like terms and then they should have same coefficient. If different, maybe they will be to be like term or not like term or not equal, everyone. So this is the example. Px comma y is 5x squared y squared minus 3xy plus 8x power 3y, and then kxy 5x power 3 plus 5x squared y squared minus 3xy. Okay, this one I leave y in x power 3, sorry, are equal polynomial. Is it okay, miss, if they change the position for the term? Yes, it doesn't matter. As long as they have the same term, same coefficient, they will call the equal polynomial. Remember that in kxy, this one is I forget to put the y. Okay, I hope you understand what I'm explaining. So now let's jump to the example. The last example for today, you need to find b if the px equal to a minus 5x power 5 minus b minus a plus 2x power 3 plus 2x, and kx equal 5x power 5 minus 3x power 3 plus 2x are equal polynomial. Remember that if they say it equal polynomial, so that's the meaning. The like terms, I like the same coefficient, it should be same, right? So you can answer this question with the two equal. So you can adding between px and then kx, the sign of the equal. So I will write to be like this: 2a minus 5 x power 5 minus b minus a plus 2 x power 3 plus 2x, it should be equal with the 5x 5 minus 3x power 3 plus 2x. Remember that they have equal, so we can use the same equal. And then look at again, they have the same term. This is same term, same term, same term, same term, and then they have same term. So this is, we can say, like terms for the first, and then because equal, they should be same coef, right? Same coefficient. So because the purpose same coefficient, we can write to be like this: 2a minus 5 is equal with the 5. So we can write 2a equal 10. So we get the a is 5. And then this one is equal with this. So because they have the same minus, you don't need to put them again. So we can write like this: b minus s plus 2 equal 3. So b minus 5 plus 2 equal 3. So b minus 3 equal 3. So you will get the b is equal 6. Okay, easy, right? So guys, so let's jump. I hope you understand. So let's jump to the last slide. So everyone, thank you for today. I hope you understand. So guys, you have the task and then more exercise. We don't need to collect, and how maybe either for the task or but you just need to work your task or your exercise. Even I don't need to collect. So I hope you understand. See you on the next meeting. Assalamualaikum warahmatullahi wabarakatuh.